So hello and welcome to today's session. So today we're going to talk on the encoders. So in the previous session we have talked about the multiplexers. You can just watch the previous tutorial, multiplexers and its application, and also we have seen how we can use 8:1 multiplexer to implement the adder, full adder, and also we have shown how we can use 4:1 multiplexer to implement the full adder. We can also implement any expression given with the respective multiplexers. So today we are going to talk on the encoders and we'll see what is an encoder. It is a slight difference with the multiplexer. So whereas in the previous multiplexer we have seen there are n inputs and there is one output, whereas the encoder is one where it has say n inputs, 2 to the power of n inputs and n outputs. So we can write like this. So let me write the diagram here. So we will talk about our encoders. So I'll take an example of 8:3 encoder. So in 8:3 encoder, I can write here with 8 inputs. One, two, three, four, 5, 6, 7, 8. So I have 8 inputs here, and the encoder will have 3 outputs. So it means it is something like this. If we have here if we have 2 to the power of n inputs, then the outputs will be represented by n. It is like this. So it means if we have 3 outputs, then it will be having 2 to the power of 3 is equal to 8 inputs. So this is how we will use to represent this. Then so let us denote this as d naught. The inputs are d naught, d1, d2, d3, d4, d5, d6 and d7, and we call the outputs as A, B and C. So we can also consider this as like converters of say any input can be converted to a binary value. For example, if we have 8 switches connected here, if any one of the switch close, then we will get the corresponding binary number here. So for example, if we close the switch, and we will get the logic 1 across this first input here, and considering that all other inputs are 0, if you consider that all other inputs are 0 here, so then the equivalent binary value that is generated, that is equal to 0, 0, 0 and 0. So in the second case, if the second input is 1, it means we close the switch at second input 1 and all other inputs remains to be 0. So then we will generate a binary value of 0, 0, 1. Then in the third case, if the third input will become 1, so if third input will become 1 here and all other inputs are 0, so then what is the equivalent binary value that is generated? So the binary value generated is that is 0, 1, 0, that is nothing but 2. So like this it can generate the binary value. So I just want to show you the quick video of the animated video of this encoder. Yes, I'll just pause it. I'll share this screen with you, so where you can see this. Okay, so hope you all can see this animated video now. So I'll put this to 0. So now you watch this carefully. So now the D naught is 0. So now how the outputs are changing, you can just watch it. You can slow this down. You can play at a slower rate. So now in this case, you see that the first input is 0, then we will get all the outputs. It is just like it is a binary generator, so all the outputs are 0, so we'll get equal to 0. So then in the next case what happens, the second input is, I'll just click here. Okay, then likewise in second input was 1, then the output was 0 0 1. Then likewise, as the number of inputs will become 1, and condition is that all other output should be 0. So that is a condition. So here we come into a problem that when both the inputs are what happens is that when both the inputs are 1, what happens? So then we enter into trouble. When both the inputs are 1, the output will be whether it's supposed to be as 0 0 0 or it's supposed to be 0 0 1. So there is a problem. So to counter that problem, we have to go for a different kind of encoder that we call it as the priority encoder. So that anyway we'll discuss later. So now let us see the truth table of this encoder, and then uh, we'll write the truth table of this encoder. So let me write here. So then my inputs are now D0, D1, D2, D3, D4, D5, D6, D7. So these are my 8 inputs here. So then my outputs are 3 outputs, that is A, B and C. So then now if this is 1 and all other are 0, then the output is 0 0 0. And in the next case, when this is 1 0 0 0 0 0 0, then the corresponding output generated is 0 0 1. Then likewise, when this is 0 0 0 1 and the remaining inputs are all 0 here, so then the output generated is 0 1 0. So then if the input shifts to next input here, that is for D4 will become 1, then all other inputs are 0, then what we get here is that we'll get this as 0 1 1. And then if the input shifts to D5, then that will become 1 and all other inputs as 0. So then I'll get this as uh, okay, I think we have missed one of the step here. So this is supposed to be 5. So basically this first condition we don't take at all. So I just written it to just show you when all the inputs are 0, we don't know what exactly it will give, but it's supposed to be 0. But the first condition we will take is that when D naught input is 1, what is the binary equivalent output we will get is that we will get the binary equivalent output as uh, 0 0 0. When D1 is 1, then we will get the binary output as 0 0 1. When D2 is 1, then we will get it as 2. Likewise, we will get for all the inputs as 1. So, but we encounter with one problem. For example, if this bit and this bit is 1, that is D0 and D2 is 1. So, what's supposed to be the output? Whether the output will give as 0 0 0 or whether the output will give as 1 1 1. So what's supposed to be the output for this particular case when both the inputs are 1? So that is a problem. So to encounter with this problem, then we have to go for we'll go for the priority encoder. So before discussing the priority encoder, we will write the logical circuit for this case. So I'll just show for 2 to 3 inputs, then remaining I'll leave it to you to write it. So let me save this page here. Okay. So I'll remove this part here so that we can see this. Yeah. So its circuit looks somewhat similar to your multiplexer, but only thing is that we don't have the additional input. That. So now it is. Now if you look into this analysis, I have just written for the sample inputs, I have not written for all the inputs. So then we will combine. Now for D4, I'll take from here that I'll combine to an AND gate. I'll take this, I'm writing only for the output A. So then I'll take the next term here, that is again D0 bar, then D1 bar, then D2 bar, which I have not shown here, then D3 bar I have not shown here, D4 bar I have not shown. D4 bar I can take from here, and D5, if I write the one more line here, if I call this as D5, so then I can take from that D5 and connect to the AND gate input here, so then that will become 1. Like that I have to write the remaining for 2 more terms, and then I have to finally combine this to an OR gate. So then I will get this output as A. So likewise I have to write the expression for B here. So here is the B.
All of you mute.
So now I have written this
If you have any doubt, raise your hand.
expression for A. This sample expression I have written here, that is D0, D1, and D3 I left it, then D4 and D5 I have written. So the first expression is, that is for D0 bar, D1 bar, D3 bar, D4 bar, and like that. D4 is died straight away, so I have connected D4, and D5 bar I have not connected, so that is assumed to be connected. So that is for the first term here, and for the second term again we have to do in the same way and then combine to an OR gate. So likewise all 4 terms are connected to a single OR gate. Then I get here the expression for, or I get the logical circuit for A. So likewise we have to do it for B. So write all the expressions, these terms here. So this one, so this term I have to take it here. So then I have to take this term here for B, and then I have to take this term, final term, and then I have to take this final term for B. So writing all these and then write the logic circuit, that will give me the output as B. So likewise I have to write for C. So this is how we can write for encoder.
Yes? Okay. Fine.
Okay.
So, in Explore, whatever.
So this is about the encoder which we are talking about. So next we will see about the
Background noise is there.
priority encoder.
Mute your audio. All of you mute your audio.
So let me take this new page here, and let me talk about the priority encoder.
Clear this. Right. And pupil will observe them. So it may be if you are showing the pictures, showing
So
the
priority
chart,
encoder is a
something.
special kind of encoder. It means it's an advanced one of the
It will
previous encoder. So the problem with the
what
previous
it
encoder
will
is that
be
if two
visible
inputs
like this.
become one, then what's supposed
And
to be the output, we don't know. So in priority encoder, what we'll
from
do
up
is that we'll give priority to
seeing
the
the
inputs.
screen,
Priority means I'll just write, we'll give importance. It's just like 1, 2, 3, 4, 5, 6,
yeah,
7.
okay.
I
And
need one
next
more
is
line.
now you
Yes.
can add some of the question related to like that here. You can add the pictures also.
So this
Here
8
some
is
more
to
pictures
3
also you can add
priority
like
encoder.
facilitated as the
So
pupil
now
the
the
question
highest
getting the
priority is
pattern
given
of
here in
data
this case
or
in my
maybe some
application
other
is
what
that
is the
for this
topic you
encoder
have
is
chosen.
the
On the
D7
basis
is
of
given
that you have to
the
ask the
highest
question.
priority.
And even here
We
you
can
can
also call
write
it as
write
E7
the
where in
question
some
related on the
textbooks or some
same
websites you can
English
call
way.
you
You
can see
can
these inputs
write the
referred by as E
answer
because it is
also.
encoder.
And
You can
here
also call
you
it as
have to
D or
write
any
the
other name, it is fine.
statement.
So
So in
basically
today's
D we use
class
for
we shall
decoder and
discuss
E
about
for
like why
encoder.
it is early like
It's fine.
user
We are
system
using the
and
term
not
here
it is
D.
only about early like
So
of
this is
addressing.
D0,
Are you
D1,
getting students?
D2. This is D3,
Hello?
D4, D5,
Hello?
D6 and D7. So here I have the outputs as A, B and C. So now let us see this truth table. If we look into this truth table here, so the inputs remains to be same, that is D0, D1, D2, D3, D4, D5, then D6 and D7. Then my outputs are again same A, B, C, D.
Okay. Right.
That is A, B and C, not A, B, C, D, it is A, B, C. So now if
So
we, is it
explore
audible now?
in the explore stage only you
So
have
now we will
to
see
ask
this
the question.
quickly.
Are
What is the
any
mean the
relation
difference
like
of
for
the priority
example
encoder?
what you did in the engage
So
stage
here
you
we
have
have
told
suppose
the
D
story.
naught is
On the basis of
1
that story you
and
can ask
say
some
all
of the
other inputs
questions.
are 0. So
And
then
here
it
also
will
you are showing
generate
the
the output as
pictures.
0,
On the basis
0,
of that
0. It is
pictures
fine.
you
It is
can
same
ask
as
the
before.
questions.
So now let us consider that
Okay. So
D1
the
is 1
last after
and
the
D naught
explore
is also
stage
1.
write down the
Then what
statement
is the output that is generated?
in today's class.
So now the D naught has got the highest priority when compared to D1. In that case, it will generate an output as 0, 0, 1. So it means irrespective of whatever the value of this D1, whether this D naught, sorry, irrespective of the value of D naught, whether the D naught is 0 or 1, it doesn't matter. As soon as the D1 is 1, it will give the equivalent binary value of D1. So now this condition we can write this as rather than 1 or 0, it can be any value. So we will write this as X. So X means it can be either 0 or either 1, it doesn't matter. So based on the condition of D1, it will generate the output. Now in the next case, if D2 is 1 and whatever may be the D1, doesn't matter. Whether it is 1 or 0, it will generate the output as 0, 1, 0. So likewise, this can also be X, doesn't matter. So whereas all other inputs are 0, 0, 0, 0. In the next case, if D3 is 1, then D3 has got the highest priority when compared to D2. So irrespective of whatever may be the value of D2 or below that, so it will generate the output of 0, 1, 1 as 3. So likewise, it has got, so this kind of encoder we call it as priority encoder. So this will give you the output as 1, 0, 0. So then this output condition is that these values should be 0 because this has got the highest priority. So the input above that has got the highest priority, below that has got the lowest priority,
Right.
right? So this
Hope
value will
clear
give
this.
us
Today
101
call is very
and
slow.
then
It is very lot of disturbance related to the
this
network
is
issues are there.
1, 0, 0,
Okay.
0,
Uh,
0, 0.
in we do
So it
one
will
thing
give
is
me
in
1, 1, 0
explore
and the
stage
last one, the
only you
highest
need to
priority
explore
is
the ideas.
this.
You
So
can
if
use some
D7
of
bit
the
is 1
questions,
and all other bits are also
pictures
1, it will generate an
related
output
to the
as
story
equivalent
questions
for
you can
only
ask or
D7
related
bit,
to the
not with respect to
whatever
any other.
the lesson
So this is
questions you
about
can
priority
ask.
encoder. So hope you have understood this session. If you have any queries with respect to encoder, you can ask.